This is 3-2, angles formed by parallel lines and transversals. Try the warm-up, pause the video, and hit play when you're ready to hear the answers. Angle 1 and angle 3 are corresponding angles. If you lift the first group of 4 up, add it to the second group of 4 angles, the 1 and 3 would line up. So those are corresponding angles. Angle 3 and 6 are in the interior and they're on opposite sides of the transversal. That's alternate interior angles. Angle 4 and 5 are in the exterior and they're opposite sides of the transversal, so that's alternate exterior angles. And angle 6 and 7 are on the interior, but they're actually on the same side, so those would be same side interior. Okay, let's take a look at the corresponding angles postulate. The corresponding angles postulate says, if two parallel lines, which we know they're parallel by the arrows here, if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So since 1 is corresponding with 3, 1 is congruent to 3, shown by the statement to the right. Angle 2 is congruent to angle 4, because those are corresponding, etc. Example 1, using the corresponding angles postulate. Find each angle measure using the corresponding angles postulate. So angle ECF is what we're going to be needing to find. This angle right here. Well, what is that corresponding to? Remember, if I pick up these 4 angles and I drop them onto the next 4, what would be in line and sitting in the same position as FCE, or ECF I should say. And that would be the 70-degree angle. So ECF is also 70 degrees. And DCE. To find DCE, since we know it's corresponding to ABC, then we could set those two congruent to each other. So we have two parallel lines cut by a transversal, and now we're looking into figuring out angle ADCE. Well, since these are corresponding, we set them equal. 4x plus 22 is equal to 5x. Subtract 4x from both sides. 22 equals 1x, or just x. So to find the measure of angle DCE, which is this angle here, we would do 5x, which is equivalent to 5 times 22, since x is 22, 110 degrees. Okay, find each angle measure using the corresponding angles postulate. Well, we know that this angle is 80 and angle x corresponds to that, so x is going to be equal to 80 degrees. So find the measure of angle, let me go back. So the measure of angle ABC then is equal to 80 degrees. Okay, angle DEF. Well, DEF is right here, and that's corresponding with angle D. I don't have enough letters to name that. So what I would do then is set these equal to each other since they are equal. Subtract x from both sides, add 45 to both sides. I just did that at the same time to save a step. And so it ends up with 1x is equal to 75. And I can plug that back in to find measure of angle DEF. So since the measure of angle DEF is equal to x plus 30 degrees, then we can go ahead and plug in x, which was 75. 75 plus 30 is 105 degrees. Okay, this next one is a two-step problem. So it's asking us to find the measure of angle QRS. Well, I see that we have a couple corresponding angles. Since these are corresponding, then 118 degrees is equivalent to x degrees. Okay, and so if that's 118 degrees, and these are on a straight line, what's the measure of this angle QRS? Well, since it's a linear pair, we would do 180 minus 118, which is 62. Let's make sure our answer makes sense. It is an acute angle, so 62 degrees makes good sense for that. So the measure of angle QRS is equal to 62 degrees. Okay, now we have three theorems. The alternate interior angles theorem. If two parallel lines, as shown by the arrows, are cut by a transversal, then the alternate interior angles are congruent. So in this case, like angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Alternate exterior angles. If two parallel lines are cut by a transversal, then two pairs of alternate exterior angles are congruent. I think you're seeing the pattern here. So 5 is congruent with 7, 6 congruent with 8. Okay, for same side interior angles, if two parallel lines are cut by a transversal, then the two pairs of same side interior angles are supplementary. So for instance, angles 1 and angle 4 are supplementary. They add up to 180 degrees. Okay, first we need to find the measure of angle EDG. I've marked this with the blue highlighter. I do know that that angle is corresponding with 2x minus 135, so I can set those equal to each other since we know they're congruent. We have parallel lines shown by the arrows cut by that transversal. So we have 2x minus 135 is equal to x minus 30. Subtract x, we end up with x minus 135 is equal to negative 30. Add 135, we end up with 105. So the measure of angle EDG is equal to 105 degrees. Okay, we're looking at the measure of angle BDG, which I highlighted for you. So when we know one angle measure, we can actually find them all based on linear pairs and these angle relationships. So if we have 75 on the top right there, since that's a linear pair that I marked, that would be 180 degrees. Well, 180 minus 75 is 105 degrees, which is what we already had for our corresponding angle at the bottom. And then remember, vertical angles are congruent, so angle FBA is vertical with angle CBD. And so those are congruent to each other. So now we can see the measure of angle BDG is equal to 105 degrees. Okay, let's find each angle measure. So since angle ABC and angle EDF are alternate exterior angles and they're congruent, so then the measure of angle EDF is equal to 125 degrees. Okay, so we didn't talk about same side interior. Same side interior angles are actually supplementary. Notice that this one's acute and this one's obtuse, so there's no way that they really could be equal to each other anyway. So the measure of angle TUS is what we're going to be looking for, but right now these add up to 180 degrees. So combine like terms and I end up with 36x equals 180 degrees. Divide both sides by 36. X equals 5. You can plug these back in and make sure that that'll equal 180 degrees. In this case, we need to plug it back in to find the measure of angle TUS. TUS is 23x, so 23 times 5. So the measure of angle TUS is equal to 115 degrees. Okay, example C now. It's sort of hard to tell what we're pointing at here, but it looks like we have ABD is 2x plus 10, and angle BDE is 3x minus 15. Since they're alternate interior angles, we set them equal to each other. Negative x equals negative 25. Divide both sides by negative, or negative 1, to make sure that x is positive and x is 25. We can plug that back in. So if we plug in 25 into the x right here, we get 2 times 25 plus 10, which is 50 plus 10, which is 60 degrees. So the measure of angle ABD is equal to 60 degrees. The treble strings of a grand piano are parallel. Viewed from above, the bass strings form transversals to the treble springs. Find x and y in the diagram. So let's see, the first thing I'm looking at here is we have angle 55 is going to be congruent to the 5x plus 4y. And angle 60 is congruent to angle, so corresponding angles, those are congruent to each other, so 60 is equal to 5x plus 5y. Now we can solve this by substitution or elimination. If we're going to eliminate something, remember it's a large addition problem. So I need these 5's to cancel each other, the 5x's. So I'm going to make all of the bottom equation negative, so that now 5x minus 5x is 0. And so I have negative 5 is equal to 9y. Not 9y, I didn't read what I wrote here. That's a negative 5y right there. So 4 minus 5y is negative 1y. Divide both sides by negative 1. And y is equal to negative 5 divided by negative 1 is positive 5. Now that we know y is 5, we can plug this in to find x. So in the first equation, where 55 equals 5x plus 4y, let's put a 5 in for this y right here. So we get 55 equals 5x plus 4 times 5. 55 equals 5x plus 20. Subtract 20 from both sides. And 35 equals 5x, and x equals 7.